So today we'll be going about normal surfaces in orthographic projections. So in the last class we went about an example for the same normal surfaces. So normal surfaces in general are the surfaces which are orthogonal to your line of sight or the visual rays coming from an observer's eye. So normal surfaces are the easiest ones to analyze because they are they can be easily analyzed by using width, depth and height method, or using by the labeling method which we went in the last class. Also, this is taken from the text or the workbook, so it is straight from there. But this is another way of analyzing normal surfaces. We would be using this method of analyzing the 3D object when we go about isometric drawings. So that means when I would be given two views and I would be asked to draw the isometric drawing, which is the 3D model of it. So, but we can still use this method of representation in order to analyze the orthographic projections on what a surface would look like in different views. Alright, so as I told, normal surfaces are always orthogonal or perpendicular to your line of sight. So there would be flat surfaces, to be simple. If you look at this 3D model right here, from the front view, there are three surfaces that I would be seeing. One is this and that, and the third one is that. So we label those three surfaces as A, B and C. So these are the three surfaces that we would be seeing from the front view. So in order to analyze a particular surface on how that particular surface would be represented in the other two views, we would need to use the normal surface table or try to understand what it would be when you visualize it. So let's look at surface A from this 3D model, which is this rectangular surface. So from my front view, that would be visible as a surface. So make sure that you understand the difference between a surface, an edge and a corner. A surface is the whole complete surface. An edge is a line of that particular surface, and a corner is a corner of that surface. So if you look at surface A from the front view, it is a surface in the front view, and that same surface would be represented as a horizontal line in the top view and a vertical line in the side view. So let's look at that particular surface. So surface A is this. So if I'm looking at it from the top view, I would only see that particular edge of surface A when I'm looking from the top view, which is 1 and 2 from that top view, which is a horizontal line. And similarly, when I'm looking at that particular surface from the right side view, I would see that surface using just by that particular edge, which is 3, 4, which is a vertical line. So if I see a surface in the front view, that same surface would be a horizontal line in the top view and a vertical line in the side. I would write this. So there would be a normal surface table that you would need to memorize or remember now to analyze the three surfaces. So let's say front, top and side. So if I see a surface in my front view, this same surface in the top view, it would be a horizontal edge, or you can call it as line, and the same surface in the side view would be a vertical edge or vertical line. So if you look at another surface from this front view, which is surface B, so right here. So surface B is a surface in the front view. So the same surface, which is this, if I'm looking at from the top view, I would see the whole surface just by that particular edge, which is 5, 6 in the top. So 5, 6 is a horizontal line, so if I see it as a surface in the front view, it is a horizontal line in the top view. And the same surface, if I'm looking from the side view, I would just see this particular edge, which is 7, 8, which is a vertical edge in the side view. So these are some examples on how you visualize a certain surface and what that surface would be like represented in the other two views. So just remember that if you see a surface in the front view, that same surface would be represented as a horizontal line in the top view and a vertical line in the side view. Let's see normal surfaces in the top view. So if I see a normal surface in the top view, so we will take the same 3D model example. So if I'm looking from the top, then I would see two surfaces, surface D, which is that, and surface E, which is that tiny little square. So there are two surfaces from my top view. We need to analyze what those two surfaces would be representing in the other two views. So let's look at surface D, which is this. It is a surface from the top view. But the same surface, if I'm looking at from the front view, I would see this edge and that edge of surface D, which is 13 and 14 from my front view. So it's a vertical, it's a horizontal line. So if you have a surface in the top view, that same surface would be represented as a horizontal line in my front view. The same surface, if I'm looking at from the side view, then I would see this edge and that particular edge of surface D, which is 15, 16 from the right side view, which is also a horizontal line. So if there is a surface in the top view, then it would be represented as a horizontal line in the other two views. So let me write that too. So I have a surface in my top view. This same surface would be a horizontal line or horizontal edge in my front view, and the same surface, I'm looking at from the side view, will also be another horizontal edge. So make sure that you read this table. This table is really important in order to analyze the different surfaces when you go about isometric drawings. Do you guys have any questions so far? Alright, so let's see normal surfaces from the side view. So if I have surfaces, normal surfaces from the side view, so in this case, from this 3D model, I have two surfaces which are normal, which is surface F and surface G. So if you look at surface F, so surface F is a surface in the right side. So the same surface, if I'm looking at from the front view, this surface, I would only see that edge and that edge of that surface F, which is a vertical line, 21 and 22. The same surface, if I'm looking at from the top, I would see this edge and that edge, which is 23 and 24 from the top. So it is also a vertical line. So if there is a surface in the right side view or the side view, then the same surface would be represented as a vertical edge or a vertical line in the other two views. So that would be the third case where you would see normal surfaces in the side views. So side view, if I see it as a surface, then the same surface in my front view would be a vertical edge. And same surface in my top view would be another vertical edge. So this is my normal surface table, and you would be using this in order to analyze different surfaces. So but you have to keep one thing in mind, that if there is a surface, let's say that surface is A, that same surface would not be a surface in any of these two views. So it would be surface in one of the views and it would be an edge in the other two views, if it is a normal surface. So in this case, this surface might be different from that surface. But this surface would be a different edge in the other two views. But for normal surfaces, you would only see that particular surface as a surface in one view and as an edge in the remaining two views. When we go about inclined and oblique surfaces, it would be a little different case. So inclined, you would see inclined surface as a surface in two views and as an edge in one view. And oblique, you would see it as a surface in all the three views. So that when you go about oblique, the normal surface or the the table would be easy, and incline it would be a little easy, but normal surface is the one that would be a little tricky. But if you know how to analyze different surfaces, then it's the easiest one. You don't have to memorize, you just have to know how to go about looking for surfaces on how they would be in another view. Do you guys have any questions? Alright, so predicting normal surfaces. So this is my normal surface table, which is the same as that. So there are different ways that you can analyze or that you can remember this particular table, normal surface table. So it doesn't mean that you will only be having surfaces. There would be certain situations where you would need to analyze based off an edge. So let's say I have a vertical edge in my top view. You need to know what that vertical edge would represent in other two views. So that vertical edge would represent a surface in the side view and a vertical edge in the front view. So the same vertical edge would represent those two in two different ways. So make sure that you remember this, and these are some of the examples on how to remember, memorize this, and we would use that in one of the examples that we would be working today. I would compare on what the label method is and what is the way of analyzing using the normal surfaces. So there are hidden features in today's example. I would also explain on how to go about hidden features. So if you have questions, ask me at any time. Alright, so normal edge table. So similar to normal surface. So as I told, surface is a surface. Edge is just the line of that surface, and corner is the corner of that particular surface. So there would be normal edge table, which we already discussed in the last example, last class, but I would go a little more in detail. So if there is a point in my front view, that same point would be an edge in the other two views. It might be a vertical edge or a horizontal edge, but that particular point would be represented as an edge in the other view. So the similar example, if I take this text and I have two edges, or this complete side is one edge, I have two labels, so let's say that is one and this is two. When I'm looking from the front view, that whole edge would be visible as a point. So that same example is right here. So if I have a point in my front view, that same point, if I'm looking from the side, it might be a horizontal line. If I'm looking from the top, it might be a vertical line. Let's see that here in this example. So I have a point in my front view. So that same point, if I'm looking, so that point would represent this complete edge from the top view. So when I'm looking from the top, it would be this edge, which is 1 and 2. So that's a vertical line. And the same point, if I'm looking from the side, it would be the same thing, so the same edge, but it would be represented as a horizontal line. So the same point in three different views, it is represented three different ways. The same edge. So this edge, 1, 2, is represented as a vertical line in the top view, a point in the front view, and a horizontal line in the side. So we need to know the normal edge table, which is, if you see a point in the front view, it would be a vertical line in the top and a horizontal line in the side. Similarly, if I see it as a point in my top view, so that point would represent this complete edge from the top. So that edge from my front would be a vertical line, from my side would be a vertical line. So if I see a point in my top view, it would be vertical line in the other two views. Similarly, if I see a point on the side view, then that particular point would be representing a horizontal edge in the other two views. So this is a normal edge table, and that one is a normal surface table. You need to memorize both the tables in order to analyze the different views and get the isometric drawing, which is our next topic. We will try to use these two tables in today's example. So I want you guys to open workbook page E17. Alright, so there is one, if I'm looking at from the front view, so if this is my front view, there's only one surface that I would be seeing, which is surface E, right? So just complete that surface, just make sure that your object lines are thick, sorry. 1, 2, 3. So so that's my surface E. So make sure that your object lines are real thick and visible from a certain distance. So make it look dark. This surface E is a surface in my friend. That same surface, if I'm looking from the normal surface table, that same surface would be represented as a horizontal edge in my top view and a vertical edge in my side, which I would be going about once I get all the three views. So is there any surface that would be hidden from my top view? From this example? Can you guys guess?
D.
There would be surface D which is hidden. So anything that is normal to the front view would be hidden if it is not visible. So in this case, the only surface that is visible is surface E. But there are two other surfaces, surface D and surface F, which are normal to my front view. That means they are flat or perpendicular to the observer's eye. So these surfaces, they are hidden. So our visibility is basically hidden by surface E. So we would need to analyze those two surfaces as well and also represent them in our front view as hidden. So if you look at surface D, let's look at surface D. Use the corner labels and get the four corners of surface D labeled on your front view. If I say this is my 1 and that's 2 and that is 3 and that's 4 of the corners of surface D. So if I take all those four corners and then transfer them onto here, then that would be 1, this would be 2, and that's height 3, so it would be 3, and that would be 4. So the way you represent this particular surface D in your front view is, so there are 4 corners for that particular surface D and there are 4 edges. So you start with each and every edge. You can start with any of the edge. So let's start with this particular edge. So if you are looking at that particular edge from the front view, it would be the same as this, right? So it is like overlapping on that particular edge. So that edge is already drawn right here. So you don't have to overlap and redraw it on top of it. It is already visible, so you don't have to show hidden lines on top of it because it doesn't make any sense. So you just have to use the same edge for that particular edge of surface D. So if you look at 2, 3, the edge 2, 3 of surface D, that would be representing the same as this. So that is already drawn, so you don't have to show it again. And I have surface 1, 4, which would be representing this edge of surface E. So that's that. So all the 3 edges are already shown. There's one edge which is not shown for that surface D, which is 3 and 4. We would represent that particular edge as hidden using the hidden line type. So you would show hidden lines right there. So what this does is, so this hidden line would pretty much represent that there is something that's been cut at that particular height. So which is this whole section is being cut. So there is nothing that is visible in that particular space or the 3D space of this 3D isometric drawing. So that hidden line would be representing this complete edge. When I'm looking from the front view, this whole edge would be visible as a point and that backside edge would be visible as a point. So this hidden line would represent the whole surface B in this case. So hidden line here is representing surface B here. So that's a horizontal line. So we need to know what that would represent in the other two views. So if it is a horizontal line in my front view, what would that be?
Surface in the top view.
Surface in the top view, and what about the side? Just look at the normal surface table and guess. So if I have a horizontal edge in my front view, it would be a surface in my top view, and horizontal edge in my side. So it's the same thing. You have to know how to read that table. I will go more about that once we complete our drawings. So there is another surface which would be hidden in my front view, which is surface F. So let's label the corners of surface F as 5, 6, 7, and 8. So I started off with surface D, but you can use your own surface labels or the corner labels and pretty much use those. Also 5 and 6. So this particular edge of that surface F would be representing this particular edge of surface E. So that's that. So it's already been given. And I have 6, 7 of surface F, which is this, which is already been drawn, so you don't have to redraw it. And 7 and 8 is also done. So the only edge of surface F which is not represented is 5 and 8. So we will need to show that particular edge as hidden from the front view, because it would not be visible when I'm looking from that angle. That particular edge is not visible. So I would need to show that edge as hidden lines going vertical direction. So from 5 and 8, that's 1, 2, 3, 4, 5 and a half on the width side. So that's 1, 2, 3, 4, 5, and that's half. So we need to start from there. Drawing verticals. So this vertical hidden line would represent that there's something that's been cut, and that vertical line would represent surface H, which is a surface in the side. Is there any other surface that I would need to show on my front view?
No.
No, there are two surfaces which are hidden and pretty much one surface which is visible, so we are done with our front view. So let's look at this same isometric drawing from the top view. Is there anything that would be hidden from the top view? So I can see surface A, B, C, and that is C. So let's change that to surface I instead of C, because we already have surface C right there. So change that to I. So I would see A, B, C, I. And is there any other surface that I would be seeing from the top view?
No.
No. Is there anything that would be hidden that I need to show as a hidden feature from the top view?
No.
No, everything is visible from the top view. So just use the label method and pretty much complete all those surfaces. That's 4, so let's start over there. Try and just make it look straight. So that would be my surface A, and that would be surface B, and surface C. And I have surface I, which is a little tricky because it's not with 1, 2, it's 1/2 on this side and 5/2 on that side. So I would go a line which is of complete width, and from 1/2 I would go that way, and from 5/2, so that's 1, 2, 3, 4, 5. That's the
So that's 1.5?
Yeah, if you count this way, so that's 1 and that's half. It's not 2.
Ugh.
So surface I, when I'm looking from the top, it's always important that you would need to know what's the width and what the depth of I would be. So the width of I can be calculated from this side and the depth can be calculated from that side. So this particular edge on the depth side is 1/2. It's 1.5 units. So that's that, which is this, and I will need to show another 1/2 right here. That would be somewhere like that, like that. And the width of this particular edge is 5/2, so make sure that you count and get that accurately drawn. I will draw this. So that would be my surface I. So that completes my surface, or the top view of this particular 3D isometric drawing. So just an example, you don't have to really analyze it now. What if I don't have this 3D object and I would just be given these two views? Will I be able to draw the third? Yes, based off the normal surface table. So you would need to analyze if I see it as a surface in my top view, what would that surface be in my front view and the side view? So you would use a normal surface table to complete the side view. So once you get your 3 views, then you can pretty much use the height, width, depth method, and then pretty much get your isometric drawing, which would be the next topic, which we would be going next.
Is it wrong to, like, for the front view, above to the top of the hidden line and then to the right of the other hidden line, to label the surface that's hidden as well?
You can have a label that can be written on top of the hidden line, but it is not recommended. It would pretty much obstruct it. I would explain on how to visualize and like pretty much get those hidden lines once I get all the 3 views. I would explain. I would come back to your question. So let's get to the side view. So do you think there's any surface that would be hidden from the side? No, I would see J, I would see K, H and G, and there's no surface that would be hidden from the side view, so just complete that using the height, width, depth method. So surface J is 1/2 on the depth side and the height of it is 3. This is my surface G, that's my H, that's my K, and this surface G, which is drawn. Just use the height, width and depth method and get everything accurately transferred onto the side. My drawing is a little off. I guess you guys know how to get those. Alright, so that's my side view. So there are no surfaces which would be hidden that I would need to represent in my side view. So I pretty much have all my 3 orthographic projections of that isometric drawing. So now let's compare all these using our normal surface table if they would make any sense. And what would those hidden, how would we need to analyze those hidden features on what they would be representing in the other views, or what it would pretty much represent as a 3D model. Let's say that I don't have my isometric drawing. Just forget about the isometric drawing. We will need to visualize based off what we have on these three views. So let's see surface E. So if I have a surface in my front view, what would that particular surface be represented in my top view? We need to basically visualize based off these three views. It would be really difficult at this point, but if you use the normal surface table, if I have a surface in my front view, that same surface would be a horizontal edge in my top view, right? So if I'm looking from the front, so there are two lines or two edges which would pretty much have the complete width of E. So E as a width of the complete, let's say that's 12 units. So there are two horizontal edges in my top view which are about the same size as surface E. So the surface E might either be this edge or that edge. But it will not be this edge because this is the back face of the object. So if you want something to be visible as a surface, it should have certain thickness, right? So if it is the back face of the object, it would not have any thickness. So this would not even be considered as a surface. So that edge would not be my surface E. So there is one other edge which would pretty much satisfy the width of surface E, which is this. So that edge would be my surface E. Right? Guys have any questions on how did I analyze that? No, alright. So let's see surface E, what would that represent in my right side? So there is the height of E is that particular edge. So I would need to see similar edges from my right side view, which is this edge and the back side edge. So what do you think? So this is the back face of the object. If this is a surface, it should have some certain thickness. So this doesn't have any thickness. So that edge can be skipped, and there's only one other. So that would be a vertical edge, which would be this. So this edge would represent surface E. So I want you guys to look into each and every surface on what that particular surface would be like represented in the other views. And let me get the 3D isometric drawing back. Alright, so now let's see the hidden lines or the hidden features that we have shown. So I would use the visual rays or the projecting lines from those hidden lines and see what that would represent in my side view and my top view. So what I've done is I've drawn a real thin line from that hidden line from the front view to the side view horizontally, and from the corners of those two hidden lines, the two corners of that hidden line vertically up to the top view. So let's see. So just remember that I would have my width and height from the front view and my depth and height from the side. So I would use this projection line, and then I would determine at what height and at what depth this particular hidden feature is being cut. So this hidden feature would pretty much represent that whole edge or that particular surface from surface B, which is from the top view. So this is the starting point of that hidden feature, and that's the ending point. So that is how much depth that particular hidden feature would have. So I would get my depth information from here. My width and height information can be calculated from my front and top views. So width is from the starting face of the object to about 4 units inside is my width of that particular hidden feature, and the depth also can be calculated from here, or you can just see where that particular hidden feature would be represented in the top. So you would need to visualize, use the normal surface table and pretty much understand what that hidden feature would represent. If your 3D isometric drawing is not given, that's when you would need to analyze this way. So similarly, if you see this particular edge, that would represent surface F. So I would use another thin line going vertically up to know what that hidden feature would represent. So in this case, this hidden line is representing that particular edge from my top view, which is surface H in my isometric drawing. And then the depth of that particular cut can be understood from here, the width can be understood from here, and the height can be understood from here as well as here. Do you guys have any questions on this example? You guys have any questions on how to go about the hidden features?
Well, okay, so if on that one, the hidden line it represents surface D from the front view.
Yes.
They're not.
Surface B. You are talking about this?
Yes.
So this particular hidden feature would represent surface B from my top.
Okay.
And that same surface or this vertical or this horizontal edge would represent this horizontal edge, which is also a surface B from my top. So this edge is representing that thing, which is a surface B, right?
Yeah.
So this would be, let me write it down. So that's surface B, that particular edge, and this edge will also be B. If you look at your normal surface table, if I see a surface in my top view, that would be horizontal edge in the other two views. So this is my horizontal edge of that surface B, and that's my horizontal edge of the same surface B. Get the point? Or do you get the point?
That was a question. That was
Okay.
Thank you.
Is there any other questions?
Would we connect that corner of E to the corner of J?
This corner of E to J? Yes. We would use the projection line method once we go about like analyzing using the miter line. That's when we would use these projection lines in order to get the third view. But at this point, know how to analyze and don't use those thin lines for now. We would go about inclined lines as well as oblique surfaces, inclined surfaces and oblique surfaces in the next two classes. So that pretty much would explain all the orthographic projections, all the different types of surfaces you would see. Then we would use this projection method in order to get the isometric drawing. That's when we would go about these lines. For now, just forget about this. Any other questions? Alright, so if you don't have any questions, there's a homework that's due today, so I want you guys to pass it on to the left side. And also remember that the place where you have your file number, right here on top, write 002, so that is your section number. So for every homework that you turn in, make sure that you have the same file number written and the file number, please. And also write your last name, first name, and also the date. So this is your homework which is due next Wednesday. It would be similar to the ones that we went over in the class today. I want you guys to analyze it, and also you would need to show your surface tables as well as corner tables for this particular homework as well. So this is due next Wednesday. Make sure that you also represent the hidden features. If you don't have any questions, make sure that you have signed them.